show that the speed of a train as it reaches the top of the vertical tower is about 20 meter per second. Calculate, assume that the resistance force is negligible, means there's no energy lost due to air resistance, and the height of the tower is 139 meters. So what happened? Again, we'll use the conservation of the energy. So the moment when it entered the circular track, it was having only kinetic energy. So kinetic energy at only there at the bottom. But when it reaches the top, so it has only energy, which is the kinetic energy at the bottom. But when it reached the top, and they mention it is moving as well. So as it is moving, so it will have potential, it's a kinetic energy because it is at certain height, which is about 139 meters. So it will have potential energy as well. So we can say that the potential kinetic energy at X, basically the total energy at X is equals to total energy at Y, but total energy at X is only the kinetic energy, and the total energy at Y is kinetic plus potential. So potential is mgh, you can substitute, you have the mass. Kinetic at Y, that using this kinetic you will find the speed, and kinetic at X it's half mv square, and we already know speed at which it entered. So we substitute that value and we'll get this kinetic energy. And using this, we get the final kinetic, and using a final kinetic, we can find the speed of the train. Is it clear?
Yes.
Just to save time, I'm not doing the whole calculation part. I'm just explaining the theory of the question. Rider will feel momentarily weightless. If the vertical reaction force becomes zero, the track is designed so that it happen at Y. Calculate the radius of a track at Y. When it appeared that weightlessness condition means the normal contact force is zero. When the object feel a weightlessness, it means there is no normal contact force object experience. So the only force at point Y which is acting is the weight. The condition, like if I say, if object is there inside a car and car is moving, an object is there inside the car and car is on the circular track. So this object experience a condition of weightlessness. What does it mean? It means it does not experience any weight or does not experience any normal contact force. So if normal contact force is zero, the only force which is acting is the weight of an object, and that weight is acting downward. So at point Y, if the object experience a weightlessness condition, in that case, there is no centripetal force. There is no normal contact force. There is centripetal force because it's a circular path, but normal contact force will be zero. So centripetal force is equals to weight only. Centripetal force is mv square over r, and weight is equals to mg. M will cancel with m, so v square over r is equals to g, or we need r here, so r is equals to v square divided by g. V was the speed at which it was moving at y, and that is already you worked out that speed in the previous part, or you can also show it's 20. So you can substitute 20 here, and the gravity is 9.8. So you will get the radius of the path or a circular path. Is it clear, this question?
Yes.
Yes, sir.
Okay. Another paper. This is January 2011. Question 5. What could be the answer? Question 5. The formula is mr omega squared. Question number 5. The object is there in a circular path. What is the force, centripetal force?
Sir, C.
Yes, C is the right answer. So you use the formula mr omega square to get the force. This is not there. It's related to electrostatics. Of course. So there was no other question. This is January 2012. Not many questions are there related to circular motion. Question 3. January 2012, question 3. What could be the answer? A student is just sitting on the right hand side of a bus facing the direction of the travel. The bus goes round a bend onto left. The student remain in the position within the bus. The student experiences
Sir, B, maybe.
yeah, B is the right answer because the resultant force is towards the result, because if a bus is taking a left turn, so you are also inside the bus, so you're with reference frame of reference, you're also moving towards left, so direction of resultant force should be towards same as the direction of the motion, towards the center of the circular or a curved path. That's why B is the right answer. Is it clear? Whenever
Yes.
whenever object changes the direction, there should be a resultant force. The resultant force can be used to change direction, to change the speed, to stop a moving object, or to make the object move, stationary object move. The potential difference is then applied and sent to a loudspeaker. Long playing vinyl disc LPs have to be rotated about 33 revolution per minute so that the encoded bumps in the groove leads to correct sound frequency. Calculate the angular velocity of LP. What's the angular velocity? You have revolution per minute. Angular velocity is radian per second. 33 revolutions per minute. What's the answer? So basically, you have to convert revolution into radian and time into second and divide.
Sir, 3.5.
3.5 radian per second. That's right. Okay, next part is as the stylus moves toward the center of LP, the encoded bumps must be fitted in a short length of groove. Explain why encoded bumps in the groove become more compressed as the stylus moves toward the center. Actually, this is the first part of a question. You can see here, this is a vinyl disc, not used now. So vinyl disc is used to store a music. How it store a music? So when the disc is played, a stylus. This is a stylus. The stylus is there on the disc. It move along the grooves. There are grooves on this disc. So as this stylus, actually groove, the disc is rotating, which cause the stylus to move as well or vibrate as well. And this rotation produce a change in magnetic field, and this change in magnetic field produce a current, which can be used to produce a sound. So now what they're saying in the question, as the stylus move towards the center. So here stylus is moving towards the center. As the stylus is toward the center, the grooves are more compressed, means the grooves are close to each other as compared to near the edges. What is the reason for that? Any idea what is the reason why the grooves near the center are compressed, whereas grooves at the edge, around the edge or near the edge or near the curved surface, it is less compressed? So basically what we want, a simple concept, we want this to take a same time to complete the rotation. Like example, when the stylus was far away from the center, if it was taking 2 seconds to revolve, we also want 2 seconds, the stylus should take 2 seconds to revolve here. Otherwise, the frequency of the sound which is released will be different. So we want the stylus to take the same time. So if we want the stylus to take the same time, here, it was covering a greater distance, so it should move faster. So as it should move faster, these grooves were not compressed, or there was a gap between the grooves. Because when the stylus enter the groove, then the stylus will slow down. So why there are grooves very close near the center, so that the stylus will take the same time to complete the rotation. Is it clear? So when it will take the same time to complete the rotation, it will produce a sound of same frequency, or the angular frequency will not change. Is it clear?
Okay.
The idea,
Yes.
because like playing a record, if you're playing a record, you want you want both of them to complete. Like example, even a stylus is near the curved surface or near the center, you want stylus to take same time to complete one rotation. So if a stylus is taking different time for a rotation, definitely near the center, as it is a short path or a small path, it will take less time to complete. So to reduce that effect, we have grooves which are more compressed, very close to each other. So when the stylus has enter the groove, it will slow down. So eventually it will take same time to cover the rotation. And when it take the same time to cover the rotation, it will produce the sound of same frequency or same time period. Is it clear?
Yes.
Yes, sir.
January 2013. in this paper, there's no MCQs related to the circular motion. It's about de Broglie's. Yeah, this one is it. Question 13. The London Eye consists of a large vertical circle with 32 equally spaced passenger cabins attached to it. The wheel rotates so that each cabin has a constant speed of 0.26 meter per second and moves around in a circle of radius 61 meters. Calculate the time taken for each cabin to make one complete revolution. What's the time period? Time to complete one revolution? What will be the time period? One revolution means one complete rotation. So speed is equals to distance over time. The distance in one revolution is 2 pi r. The circumference of a circle is same as the distance travel in one complete rotation. What's the answer? How much time it takes to complete its one revolution?
So the speed is 0.26.
A speed of 0.26 meter per second, yes. Speed of the cabin.
So 1474.
Just 1474 seconds. This is the time it will take, the one passenger cabin will take to complete its rotation or revolution, one revolution. The next part, they're asking for the force acting. Calculate the centripetal force acting on the cabin. So you have the speed, you have the radius, you need the force, the centripetal force. What's the answer for centripetal force on the cabin?
So what was the formula?
Formula for centripetal force, mv square over r, or mass speed square divided by r. You have the mass, you have the speed, and you have the radius. What's the answer?
10.7.
10.7 newtons. Yeah, that's right. Okay, that's good. Next part. This is a cabin. You can see the vertical plane. The diagram shows just the circle and the cabins. Draw arrow to show the direction of a centripetal force acting on a person in a cabin when the person is at each position, A, B, and C. At A, what will be the direction of the centripetal force?
Down.
Down. At B, what is the direction?
Left.
And at C, what is the direction? Up.
Up.
Because the centripetal force is always directed towards the center. That's why it's at A it is down, at B it is towards left, and C is towards up. Next part, this is a 4-mark question. As a person in a cabin moves around the circle. So a person is there inside a cabin and is moving. The normal contact force between the person and the cabin vary. Like the normal contact force is actually the force which is balancing the weight. That's the normal contact force. State the position at which this force will be maximum and position at which the force will be minimum. And this is the question. You can see the picture and you can identify at which position the force is maximum and which position the force is minimum. The normal contact force. Yeah, what do you think? The normal contact force, maximum and minimum. You can work out with a formula as well. A simple way to identify first what do you think where it will be maximum and where it will be minimum, the normal contact force. A, B, or C?
Maximum at C.
Maximum at C, that's right. And minimum at?
A.
Minimum at A, that's correct. So reason for that, a simple way to understand this concept, the weight of a passenger is acting down. The normal contact force acting, because the normal contact force perpendicular to the surface, so weight is down, normal contact force is up. And the result of these two gives a centripetal force. So I can say centripetal force is equals to weight minus normal contact force. So the weight is acting downward, weight is equals to mg, and the normal contact force is there, which is acting up. Or I can say R minus W, W minus R, or R minus W, it's the same thing. Because a normal contact force, how a normal contact force will, it's a force which is balancing the downward force. So simply what I can say, there's a downward force, the weight is there, and there's a normal contact force. So W is downward, R is upward, two forces are in opposite direction. So when two forces are in opposite direction, the result of these two will give us the centripetal force. Or I can say the normal contact force is equals to centripetal force plus weight. So that's why at C it will be maximum. And what about A? When you check A, at position A, so here weight is acting down, normal contact force is acting up, weight is acting down, but the normal contact force should be more because we need a resultant. So this one is weight acting down and normal contact force is up. So that's why we wrote W minus R is equals to centripetal force mv square over R, or W minus centripetal force is equals to R. That was for A. And for C, the normal contact force should be more than the weight so that the resultant force is towards the center. So R minus W is equals to centripetal force, or R is equals to W plus centripetal force. Is it clear? So the distribution of the marks, like first you will mention where it is maximum and where is minimum. Then you can use these equations and you can mention the statement that the centripetal force is a resultant force. So at position A, the resultant force is downward. So that's why weight should be more than centripetal. At position C, the resultant is upward. So normal contact force should be more than the weight. So these are some questions related to the centripetal motion, like the circular motion. Next class. Okay, so I'll end the session and share the recording. It's better you solve the question topic wise. Like example, as we discussed momentum, you solve January session already. I discussed all with you, almost all. So you can do practice with June, and same with circular motion.